One thing that you will most certainly run into at one point or another when working with Microsoft SQL Server or any other relational database management system or RDBMS is blocked processes caused by locks on database objects. But what are database locks and why can they sometimes cause one process to block another? Locking is an integral part of any successful processing of transactions in any good RDBMS. The reason for this is the need for data integrity within the system. One of the important ways RDBMS keeps the integrity of the data stored is by making every transaction pass the acid test, which means it meets the following criteria. Atomic. The transaction performs in an all-or-nothing fashion. Consistent. Transactions are processed in a uniform manner. Isolated. Transactions are properly isolated until they are finished. Durable. The RDBMS will maintain a record of uncompleted transactions in the event of recovery during a failure. The isolation part of the acid test is addressed by locking objects, in most cases one or more rows of data, until the associated transactions are completed. The locking of objects stops all other processes from being able to change these objects until the lock is removed. Blocking is the logical outcome of locks being issued against various objects in a database. If a request is made against an object which has a lock issued against it, then the request is delayed until the lock is removed. The delaying or stopping of a transaction is referred as a block. An example of this would be if request A is attempting to insert a row in table T. Subsequently, before request A completes, request B submits an update on table T. If the row affected by request A is also affected by request B, then a block is encountered. Because the row affected by request A has an exclusive lock issued against it for the duration of the transaction. There will always be some level of blocking in an SQL Server database. This is the natural outcome of the goal of 100% data integrity and the resulting need for locks. High levels of blocking or blocks that are not quickly resolved can become a major concern. Blocking can impact a company's ability to keep its data current, and it can also affect the end users of that data, such as clients coming to its website. One of the most common symptoms of excessive blocking is high SQL Server wait counts, which in turn can cause slow response times to requests made on a database. There are a number of ways to locate blocking issues in SQL Server, and in turn, the system process IDs, SPIDs, involved in blocking. If you have the correct SQL Server permissions, here are two of the easiest ways to find them using SQL Server Management Studio. To find blocks using this method, open SQL Server Management Studio and connect to the SQL Server instance you wish to monitor. After you have connected, right-click on the instance name and select Activity Monitor from the menu. SQL Server Activity Monitor 1. Once Activity Monitor has loaded, expand the Processes section. Any processes which are currently in a blocked state will display the SPID of the processes blocking it in the Block By column. In the example as follows, we see the SPID 55 is being blocked by SPID 54. SQL Server Activity Monitor 2. SQL Server System Stored Procedure SP_who2. To find blocks using this method, open SQL Server Management Studio and connect to the SQL Server instance you want to run the stored procedure on. After you have connected, right-click on the instance name and select New Query from the menu. SQL Server SP_who1. Once the new SQL Server query window opens, type the following TSQL statements in the window and execute them. Use master, go, exec sp_who2, go. A list of processes will be displayed, and any processes which are currently in a blocked state will display the SPID of the processes blocking them in the block by column. In the following example, we see that SPID 55 is being blocked by SPID 54. SQL Server SP-WHO2. Understanding which queries and processes are causing blocks is important in helping make sure your website is running smoothly and providing the best experience for its users. Blocked processes caused by locks on database objects are a common issue. Locking ensures the integrity of data stored within databases by forcing each executed SQL Server transaction to pass the ACID test, which considers that every transaction must meet the following requirements. Atomicity. A transaction must be either fully completed when executed or it will not execute at all. Consistency. Transactions must create a new state of data that is valid, or if any failure occurs, it must return all data to the state that was actual before the transaction is executed or started. Isolation. A transaction that is in process of execution and is not committed yet must be isolated from all other transactions. Durability. Committed data must be saved in a way that will maintain data in correct state if a transaction does not complete in the event of a failure and restart of the system. As part of the ACID test, isolation is carried out by locking effects objects, and as such, isolation can affect one or more data rows until the SQL Server transaction that is executed against that object is committed. This means, in practice, that by locking the object, SQL Server will prevent any other process from making any change against the data in that object until the lock is removed, either by committing the change or rolling it back. Imposing the lock over an object will cause any other process that imposes a request against the locked object to wait until the lock is removed, which will delay execution of that process. The state when a transaction is waiting for the lock to be removed or stopped is what is known as a block. SQL Server is designed to work this way, and as such, blocks are not inherently problematic. Therefore, only when a high level of blocks is detected on SQL Server, or in a case in which blocks occurs that require excessive amount of time to be resolved, should it be treated as a potential issue. A practical example of SQL Server blocking is when transaction number 1 is trying to update data in table A, and while transaction 1 is still running and is not completed, transaction 2 tries to place a new lock on table A. If the row that should be deleted is also the row that will be updated by transaction 2, then transaction 2 will encounter a block. This is because transaction 1 has an exclusive lock imposed on the table while the transaction is running. So, how do we identify instances of SQL Server blocking? There are a couple of ways to do this in SQL Server. First is using Activity Monitor, and second is using SQL Server DMVs. Activity Monitor is an SQL Server Management Studio tool that enables users to see details of existing SQL Server connections, and it can be used to show information about the open processes and locks on SQL Server resources. To open Activity Monitor in SQL Server Management Studio, right-click the SQL Server name in Object Explorer and click Activity Monitor. Expand the processes and locate the process that is waiting. Once the process is located, take a look at the Blocked By column to find the process ID that has caused the blocking. Now, when the process that is causing the blocking is identified, it has to be located in the same processes page. Now, when the information about the process that is causing the blocking is found, the user might opt to kill that process or to allow it to run until it completes. To kill the process, right-click on it and select Kill Process. The Dynamic Management View, sys.dm exec request, is used for identifying the SQL Server blocks. It can be used to list currently active blocks by executing the following query. Use master, go, select session ID, blocking session ID, wait time, wait type, last wait type, wait resource, transaction isolated, on level, lock timeout, from sys.dm exec request, where blocking session ID, less than greater than 0, go. In the results, it can be seen which process is blocked, session ID, what process is blocking session ID, what wait type is involved, and what the wait time of that blocking is, as well as the resources involved. To terminate the blocking session, ID 74 in this case, use the kill command, kill 74, go. Here's a quick tip. Take care when killing a process and make sure that there is a complete understanding of what that process is doing and why it is causing blocks. When a transaction is killed, all data changes made by that process to be rolled back into a previous state. But these native SQL Server methods can be used only for detecting and identifying active blocks. In many situations, when a block is detected and identified, it is important to know whether this constitutes normal behavior and whether it occurs rarely or only once. Without such information, it is not possible to perform required troubleshooting, simply because no historical data about blocks are available, such as blocking frequency and the extent of blocking. This is why a third-party performance monitoring tool like Apex SQL Monitor can be helpful. Apex SQL Monitor is a performance monitoring tool that can track wait statistics on the individual query level, store data in a central repository database to ensure easy access to historical information. To use the Apex SQL Monitor to identify the SQL Server blocks, select the SQL Server instance in the left pane that you have to troubleshoot. Go to the Query Weights tab by selecting the charts in the main menu. Now select the Query Weights tab and check the Block Queries radio button. If there are any blocked queries, they will be listed in the grid and displayed in the chart. By expanding the specific query on the plus sign at the beginning of the row, details about that query block will be displayed. Here, the most important information is related to the blockers section. Information about SPID number of the process that is causing the block, and resources involved in this block, wait resource. For better understanding of how to decipher the resource, please refer to the Microsoft article, INF, Understanding and Resolving SQL Server Blocking Problems. Every block is actually a situation when one process is waiting on another process to release the lock, so SQL Server will register that wait using the LCK_M_XXX wait type. Depending on what the blocked query is waiting for, this query wait will be displayed. By mouse clicking on the wait type name, helper information about the wait type and advice on resolution with additional links to resources about that wait type will be displayed. So now it is easy for the user to get detailed info about not only the current blocking, but also about all blocks that occurred in the monitored SQL server. Users can now easily analyze how often the specific query has been blocked and by what processes. To check the history of the blocks for that particular query, access the History tab. As it can be seen from the image, this query has been blocked only once during the day by process SPID 74. But if we check the other blocked queries, it can be seen that it is always the SPID 74 process that is involved in all blocks. This seems like actionable information that could be further investigated. In addition, it is good advice to check the previous days for blocks that occurred in order to better understand when, why, and how it occurred. To do that, select the previous day, for example, from the date picker in the Query Weights tab. The SPID 72 was blocked 4 times during the previous day, and after taking a closer look at the details, it can be seen that SPID 72 was itself blocked by SPID 74. Based on this, there is reliable evidence that it is not just a rare case of blocking, but that blocking occurs regularly and is caused by SPID 74. Therefore, SPID 74 and the query behind that process ID is causing the blocks, and the SPID 74 query must be investigated more closely. In order to track the blocked query or queries for easier and faster inspection in the future, assigning an alias to that query, example, blocked update table X, will ensure that the query will be noticed easy if the situation repeats itself. To do that, go to the Rename tab. Insert the desired name. Descriptive or names according to company convention are recommended. And then save the change.